My name is Esteban Bolio. I have been taking the IBM data specialization, and in this project, in this video, I will present to you my data science project. We will start presenting the use case, then we're going to present the data set, and we're gonna present which modules we take. After that, we are gonna introduce our architectural decisions, which future engineer we use, and we're gonna present to you our Jupyter notebooks and how our algorithms work. Hello, stakeholders. This is this is the data set we got from Kaggle. As we can see in the left, we have a day column, then we have a time column, then we have a username. The username is the name of the person who were wearing an accelerometer. Then we have the wrist, is if the accelerometer is on the right or left hand, the activity, 0 for walking, 1 for running, and then we have the three axes from acceleration and the three axes from the gyroscope. Next, we have the use case, and the use case we have to determine if a person is walking or running for exercise applications. As we can see, we gonna try to predict if a person is running or walking based on the information from the accelerometer. Well, this is our case solution. We made a project titled Run or Walk, and it was made on PySpark, on Jupyter Notebooks, and in our evaluation, we got an 86% and 96% of accuracy. The first one was our machine learning algorithm, and the second one was our deep learning algorithm. Here we present our architectural choice. First, we choose to use a Parquet file for machine learning and a pandas.frame file for deep learning. The Jupyter Notebook as our main developer environment, and GitHub as the repository for the project. Then the data preprocessing and future engineer. The data was converted to a Parquet and a pandas.frame file, as we say in the last one. And for a future engineer, it was used normalization, string indexing, and vector assembly. The model performance indicator and model algorithm. The model algorithm for machine learning was linear SVC classifier. For deep learning, the use loss function was binary cross entropy, and the model performance indicator was accuracy for both of the models, making it easier to compare which one is better. We can see the data exploration of our data sets, and we have the correlation. We explore the correlation between the activity, that is our tag, and the three axes of acceleration. We can see that the x-axis have a low correlation, but our y and z-axis have a correlation that it's about the minimum to be considered. Then we see the correlation between the activity and the risk, and surprisingly, the correlation is up to 0.1. And at first, our hypothesis was that the risk and the activity had absolute no correlation. For the data visualization, we plot time versus y acceleration, we see that we can see a defined pattern here, and the same happens with time and z acceleration. And then we plot in a scalar plot y acceleration versus activity, and last activity versus z acceleration. Here we are in our Jupyter notebook for our final project. Here we have our first algorithm for machine learning. We use linear SVC with 40 max iteration and 0.01 of our parameter. Then we go and we can see that our algorithm works well, and then we evaluate the algorithm using accuracy. And as we can see, we get 0.86, a great evaluation. Finally, we evaluate our deep learning algorithm. The loss function is the binary cross entropy. And again, our metrics here, we call them, that is accuracy. So we execute. It's gonna take a little while, so we are gonna wait because we have 100 epochs. As we can see, these are the epochs, and we can see how the accuracy is going up. We have already 14, 15 epochs. We're gonna go into the future to go to the last epochs because it's getting a long time. Here we are a little in the future. We get 95, 96, and we can see the accuracy now is up to 0.95 or 95%. And we are almost, and we get into up to 96%. So as we can see, our deep learning algorithm was such a success. As we can see, then we compare our results. We can see that we can predict if a person is walking or running with an accuracy of more than 85% for our machine learning algorithm, and over 95% for our deep learning algorithm. Therefore, while we conclude that the best approach for this project is to solve through deep learning. Well, that's the end of our project. I hope you like it, and well, I want to say thank you for IBM for this incredible course.